Hi everybody, and welcome to our last section of notes for the school year. This is Unit 12, notes number 2. We're continuing with circles, but this time we're going to focus on the area of the circle and something called the area of a sector, which is just another name for like a pie piece. Okay? So first let's just practice area. So just as a quick recall, the formula for the area of a circle is pi r squared. So we're going to use that for our problems here. And notice that I'm going to ask you a little bit about diameter and radius again, just to make sure you remember. So for number 1, we've got circle O. And right now they've given us the radius, but we want to also know what the diameter is, just for informational purposes. Remember that the diameter is 2 times the radius. So therefore, if we just do 2 times 5, that will give us 10. So the diameter is 10. Now, as far as the area is concerned, we're using that pi r squared. And just like last time, we're going to express our answers in terms of pi, and then again as a number rounded to 2 decimal places. So plugging in the r as 5, that's going to give us pi, and then the 5 being squared. According to order of operations, make sure you do the squaring part first. So that's going to give us 5 squared, which is 25. Now I know that the 25 is to the right of the pi, but we like to switch that around. Remember how we said that we treat pi almost like it's a variable, okay? We just keep pulling it along, and then in the end, it's at the end of our answer. So in terms of pi, this is the area. Grab a calculator to know what that really would mean in terms of real world units. 25 times 3.14, and that would give us 78.5. So let's say that radius was 5 feet. The area would be 78.5 square feet. Again though, we talked about how in SATs and different types of standardized tests, they like to leave things in terms of pi, and that's why I'm requiring that you give me both. And let's just do one more to fine-tune our area and our knowledge of the relationship between the diameter and the radius. And now we're going to move on to those sectors. So for number 2, they ask us for the length of the radius, because right now, notice that they've only given us the diameter. So we have to remember that the radius is just the diameter divided by 2. So we're just going to take half of that diameter, so it was 18. And when we divide it by 2, we're going to get 9. So the radius is 9. I'm just going to write that underneath there, just for clarification. Because when we go to find the area of the circle, we're really going to need that, because the area of the circle is pi r squared. Again, the r that we found was 9, so we're going to go ahead and plug that in to the r position. Then, according to order of operations, we square that 9. That'll give us 81. And then, of course, we'll just throw that pi at the end. So in terms of pi, this circle's area is 81 pi. Grabbing my calculator, 81 times 3.14, that's going to be the same thing as 254.34. Again, like before, guys, we're just using the 3.14 for pi. And traditionally, again, speaking about other tests that you may take in the future, if they don't want something in terms of pi, then they'll tell you 99% of the time, they're going to just say use 3.14 for pi. So that's what we're doing as well. So that's just a quick review of finding just the area of the circle. Because now what we're going to do is we're going to find a sector. But let's again just clarify what we mean by that. So a sector of a circle is simply a pie-shaped portion of a circle enclosed by 2 radii and an arc. So kind of like when we talked about the arc length, basically it's formed by going from the center out, and of course, here's your little arc. But now what we're going to talk about is the actual space inside there. So The actual sector is going to be the actual pie piece, okay? So I'm actually going to put that there. So it's the pizza slice, it's the pie piece. We're actually looking to find the area inside, whereas the arc length was just that outer rim. So therefore, we're going to actually use the same formula that we did for arc length, except now we're going to substitute the circumference formula in for the area formula. Or whatever. You can see it. All right, so our formula for the area of the sector, again, we're going to use x for the area of the sector. And based on the angle that was formed, remember we talked about the central angle? The central angle is simply just that angle right there that's formed at the center of the circle, and it's with those two sides being the radii, the radius, plural. Well, this is the same idea. We want to know that angle because that's what's going to go on top of here. So the central angle will be over top of 360 degrees because that is the entire degrees in a circle. And then the area of that sector is going to go over top of his total area, which would be the area of the circle. So again, it's the same relationship, pretty much that same formula that we did with arc length, except now right here, we have the area formula instead of circumference. So make sure you're definitely using the right formula. So if they want the area of the sector, use the area formula. If they want the arc length, make sure you're using the circumference formula. And now let's just do a couple problems to practice, and then we'll be all done. In fact, these problems probably look a little familiar to you because if you did watch the arc length video, they're the exact same ones. What I did is obviously I changed the directions. Now I'm asking for the area of each sector, and then also notice that they're shaded in. So that will be, in my case, a big red flag that you want area because you're going to have that shaded pie piece there. So because I'm looking for area, remember to use the pi r squared. In fact, I'll write our little formula up top. That's the formula we're going to use. So looking at number 3, again, our angle is 120. So that'll be 120 over 360. X will be the area of the sector we're looking for. But now in the denominator here, we're going to use that area formula. So it will be pi, and in place of the r, we're going to put the 3. And don't forget to square it. Again, at this point, I like to just clean things up a bit. Feel free to reduce this left fraction if you'd like. Mainly at this step, what I usually do is just clarify this part here. So I'll clear that up. I'll say, well, I know that 3 squared is 9, so the area is 9 pi. And now my job is to cross multiply. So that's going to be 360 times x, so I'll have 360x on one side of my equation. Over here, I'm going to do 120 times 9, and whatever that gives me, I'm going to put that pi right next to it. That gives me 1080, and there's that pi. And then we're going to just simply divide by the 360 on both sides. Again, just leaving that pi exactly as you see it. We just keep carrying it down. And that gives us 3 pi. Now, just like we talked about with the arc length, double check that it makes sense. Basically, this denominator here is the area of the entire circle. So this being less than that makes sense. We also want to know the decimal, so we just do 3 times 3.14, and that gives us 9.42. So again, we want to make sure that we're familiar with in terms of pi in addition to the decimal. All right, and last but not least, we're going to do number 4. Again, looks super familiar, except now instead of finding the arc length, we're finding that entire pi piece. So we've got our formula again, but this time we're going to use a 45 over 360. And then of course we've got a 14 for our radius. And I'm just realizing now how big this is going to be. So again, make sure you got your calculator handy. Okay, 14 squared is going to be 196. So just cleaning up that right side, I'm just grabbing my calculator here. I get 196. We're going to go ahead and of course cross multiply. So that will give us 360x. Over here, we're going to have to do 45 times 196. Yowzers, 8,820 pi. Not sure if it's perfectly divisible by 360, but again, if it's a decimal, it's a decimal. We'll just deal with it. 5 by 360. Okay, decimal, but pretty. You know, just like I thought it would, because, you know, 24.5 pi. Again, just double checking, the entire area of this was 196. Therefore, this definitely must be less, and in fact, it must be a lot less because notice that that little sliver is not that big compared to the entire pie, the entire pizza, if you will. When I times the 24.5 by 3.14, I get 79. Oop, no I don't. I get 76.93. And that is finding the area of a sector. Again, guys, I chose these concepts, the arc length, the area of the sector, the circumference formula, because these are things I see most, occur most with SATs and different types of standardized tests. So I hope you enjoyed this heads up of that material. Obviously, when you go and take those tests, you might encounter some more difficult problems. So make sure that you do practice before doing an SAT, a PSAT, etc. But this should give you at least enough background knowledge to feel comfortable kind of moving forward. And that's all, guys. So I just want to say, I know this year ended the way it did, but I'm very thankful that we all had our classes together. Every single one of my geometry classes this year were so great. And I'm sorry that I can't be there to say this in person, although it would probably be more embarrassing because I'm going to cry. But it's really great when you have a group of kids that you really feel that you guys can have fun with, but we can also learn and we know when to kind of get down to work and when we can have some fun and stuff. So I just want to say thank you for a great year. I know only about 5 of you guys are probably watching this video, but I do appreciate everybody. And have a good summer and stay healthy and stay safe, and hopefully I will see you in the fall. Okay? See you later. Bye.